Hey everybody, this video has sound, so hopefully you can hear it. Otherwise, you're going to see me pointing to this sign and hopefully getting your sound up and running. This is the lesson, Chapter 11, Section 1, or 11.1, out of the Geometry Chapter 11 Study Guide. This is a lesson on a topic that many of you have already worked with before. Basically, it's finding areas of figures, like parallelograms and rectangles and triangles. So, just to review some basic concepts, the base of a parallelogram, it can actually be any side. It all depends on how you're looking at the shape. If you're looking at the shape like this side right down here is the base. Or, if I flip the shape to a different orientation, then this side here would be the base. So basically, if you think of this shape as an object and it's sitting on a shelf, whatever the side that it's sitting on is the base. Now, the height. The height is always measured, this is very important, always measured straight up and down. Very, very, very important. So, you cannot measure the height of this object if you measure this way. Do you see how I'm kind of measuring not straight up and down and measuring diagonally? That's not the height. The height of this would be from the highest point, which would be somewhere on the top, down to the base. So on this one you could measure the height if it's given to you kind of on the side, as long as it's straight up and down from the top to the bottom. Or you could measure it in the middle, again as long as it's straight up and down from top to bottom. This one, you could measure the height through the center of the shape, or on the side somehow, as long as it's straight up and down from the very highest point to the very lowest point of the object. A few little postulates here. Basically, they just say that the area of a square is the square of the length of a side. Now, I always say that a square the area is side times side. Now, that can also be written in condensed form by using the power of 2. So that's what this postulate says, is that the area of a square, this is a side, is side squared. I prefer to think of it as side times side. The reason why I like to think of it as side times side is because a square is just a more specific type of rectangle. It's a rectangle where all 4 sides are congruent. And a rectangle is a shape where you find the area by multiplying the length times the width. And that's really what you're doing when you're just saying side times side up here. A parallelogram, which is what I drew up here, is a shape where the opposite sides are parallel to one another. You can see that these, at least I attempted to, this one's a little bit wonky, but there you go. It's a quadrilateral where the opposite sides are parallel. And it turns out that all you have to do to find the area is multiply the base times the height. And we talked about how to identify base and height in this definition up here. Okay, the area of a triangle is half the product of, product means multiply, the base and the height. Okay, now sometimes you have triangles where the base and height are sides of a triangle, like this. On this triangle, it's sitting on the base here as we're looking at it. And the height, remember, has to be measured straight up and down from the highest point on the shape down to the base. So since this is the highest point in the shape and this side is measuring straight up and down, then this would be the height. Sometimes triangles don't look like that. Sometimes they look more like this as you look at them. As you can see, this would be the base here. It would be sitting, if it was sitting on a shelf, this would be where the side it's sitting on. So that would be our base. And then the height, again, is measured straight up and down from the highest point straight down to the base. So this would be the height right here, from here straight down to there. Either way, the area is 1/2 base times height. The area of a rectangle is length times width. And as I mentioned up here, the area of a square is side times side. Postulate number 25 is pretty straightforward. It simply says that if two polygons are congruent, that means they're exactly the same size and shape, then they have the same area. That makes sense. They cover the same amount of surface if it's the exact same size and shape. Number 26 postulate says that the area of a region is the sum, that means adding, of the areas of the overlapping parts. So basically this one, I'll draw you a picture to help you understand. You have, let's say, a triangle. It doesn't matter. It can be any type of region. Doesn't matter that if it's a particular shape. It could be a shape that looks kind of like a lake. Okay, so I'm just going to draw a triangle. That's my region. It says that if you have parts inside here, if you, for example, section it off into two pieces like that, you know, where you have part A and part B inside the entire region, it says the area of the entire thing can be found by adding up the areas of the parts inside. That's what postulate 26 says. Alright, so on the following pages we have some examples of how to apply these formulas, or these concepts. This shaded area here is a parallelogram. I know that because the top and the bottom are parallel and these two sides are parallel to each other. Now, I have a base down here. See, it's sitting on this side right here. So I have a base of 9. And that can help me find the area of a parallelogram because I just need to multiply the base times the height, right? So I already know the length of the base. Now I need to figure out how tall this object is. So I'm looking for a height, a measurement, that is straight up and down, and it runs from the highest position on the shape, which is up here, down to the lowest position on this shape, which is the base. So as you can see, this little thing here that is telling you that it's 90 degrees to the base, that runs from that level all the way up to the top, that is our height right there. Not this. You can see this is not a measurement of height. It runs diagonally through the shape. It doesn't measure straight up and down. So for that reason, we have both the numbers we need, the height and the base. And if we multiply them together, we get 36 square units in area. Now, if they don't give you feet or inches or yards or meters or whatever unit to use, what you can do is you can just write a generic UN that stands for units. That means that you don't know what they're measuring in, but it's something. And then also, this is very important, we say square feet and square yards and square inches, but we always put the square on the upper right hand portion, not over here. Do not put the square here. That changes the answer to a wrong answer. Okay, so this is 36 square units, but we write it 36 units squared. Okay, find the area of the region. Well, this is a triangle. The formula for the area of a triangle is 1/2 times base times height. Well, this is what it's the side that it's sitting on, so this is my base, and it's made up of two sections. It's got the 45 and then the 21. So this entire distance all the way across can be found by adding 45 plus 21, which is 66. So that's going to be my base. And then the height is always measured on any object from the highest point straight up and down to the base, right? So that would be 28. So if you're using your calculator, instead of using 1/2, you could use 0.5 and multiply that by 66 and then multiply that by 28. And you should get 924 square units. The next shape is a parallelogram. You can tell that because they've marked this side and this side parallel with the little arrows, and this side parallel with arrows as well. Now, this is our base right here. And since it's a parallelogram, the opposite sides are always equal in length. So if the top part is 17, that means the bottom would also have to be 17. Remember, the area of a parallelogram is just base times height. The base being 17 units long, and the height. Well, we're looking for a length that runs straight up and down from the highest level down to the lowest level of the shape. So it would not be the 10. The 10 is not straight up and down, it's diagonal. We don't want that. We want that length that is straight up and down, so that would be 7. Multiplying those together gives you 119 square units. Again, don't forget to put the square here, not here, for your final answer. In example number 2, they're talking about a triangle. And they say that the height, which on this triangle would be here, and the base have a certain relationship. It says the base of the triangle is 4 times the height. So the distance here is 4 times the amount of h, so we're going to call that 4h. Now it does also tell us the area. So what do they want us to find? Well, they want us to find the base and the height. Okay, well we can do that as long as we only have one variable identifying them, and we do. We've identified the height, and then we've identified the base, not as b, but we've identified it using the h. So that means that when we create our equation, area equals 1/2 base times height, because that's what the formula for a triangle is for area, right? We know everything except for the base and the height, but both of them are in the same variable. They both have h. And that is important because when we use equations, we want to only have one unknown letter. All right, the base is 4 times the height, so I'm going to call that 4h. And the height, we called that h, so we'll continue calling it h. So here's what we do. We have 50 on this side. The half and the 4 can be multiplied together. Half of 4 is 2. And the h times the h can be multiplied together. That gives you h squared. So if you have 2h squared equals 50, you can start solving for h by dividing by 2 on both sides. And you get h squared equals 25. And if you continue solving, we can do that by taking the square root of both sides to cancel the square. So we have a height of 5 units long. Oh, 5 inches, hey. We have units here, so we'll use them. The base is 4 times the height, so that would be 4 times 5, or 20 inches. And there you go. We found the base and the height. Here it says a parallelogram has an area of 133 square feet and height of 19 feet. What is the base? Well, remember, a parallelogram, the area is just base times height, right? So really the only thing that we don't know is the length of the base, that's b. Everything else they gave us. So we can use this formula as an equation with only one thing we don't know, that's b, and we can solve for b, as long as we have the other two numbers, which we do. So a parallelogram has an area of 133 square feet, so that would go in for A. B we don't know, and the height is 19. So basically on this side I have 19b, and over here I have 133. I like to write that the other way around, 19b equals 133, and then divide by 19 on both sides. So the length of the base is 7 feet. Okay, so it says a robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes. How long does it take for it to clean the carpet covering a room with the dimensions shown at the right? Okay, well, basically what I'm going to do is I'm going to section off this room into 2 pieces. Remember, if you recall, there's a theorem that says that we can section something off into 2 pieces and then find the area of the whole thing by just adding the areas of each piece. So that's what we're going to do here. I think first if I find out how big it is, and then if I can figure out how many 2 square meters are in this area, knowing that each 2 square meters that I have, it takes 8 minutes, I should be able to figure out how to calculate the total time that it would take for the vacuum to clean the whole room. Okay, well, it seems to me like this is a rectangular room. I think that's a fair assumption. This down here, assuming that we have all right angles here, would be a square, right? So the area here would be side times side, 5 times 5, or 25 square meters. Up here, it looks like we have a rectangle, again, assuming all the corners are right angles. If this side is 9, and this much down here is 5, that means that this part up here would be 4, because 4 plus 5 is 9, right? 9 in the middle marks the entire length here. So the area up here on this rectangle, again, length times width would be 4 times 9, or 9 times 4, whatever, which gives us 36. So the entire area can be found by adding the top part, the rectangular part, plus this bottom part, the square part, together. So the total area is 36 plus 25 or 61 square meters. Okay, so going back to figuring out how much time it would take to vacuum this area. This is the information they gave me that's pertinent. It says that 2 square meters, which is a lot less than 61 square meters, takes 8 minutes to vacuum. Okay, so if I can figure out how many 2 square meters are in 61 square meters, then I can figure out how many 8-minute chunks I would have inside this shape. So first I'm going to take 61 square meters and divide it by 2 square meters, and I get 30.5. So I have 30.5 sections in here that each take 8 minutes to vacuum. So if you can imagine, 2 square meters is maybe this big, and there are 30 of them in here. So since each one of these sections takes 30.5, there's 30.5 of them, and each one of them takes 8 minutes to vacuum, all I have to do to find the total time is multiply 30.5 times 8 minutes each, which gives me a total of 244 minutes. Now, you could certainly leave that answer that way, or if you'd like this answer in terms of hours, we could do a conversion. We could take 244 minutes divided by 60 minutes per hour, and we'd get about 4.07 hours. I'm not going to do the challenge example. It's actually pretty complicated because there's no numbers in it. So if you feel like you're really, really good at algebra, you can go ahead and give that a try. I'm going to leave that up to your individual teacher to maybe practice that in class, because you might need a little help. Alright, so the last example I'll do for 11.1 is this one. Again, I think it's hard to find the area of this shape because there's no formula for the area of this type of shape, but there are formulas for shapes that we see inside here. So we're going to use postulate 26 again, that says that you can section off a whole shape into smaller pieces and then add up the areas of the pieces to get you the total area. What I see is I see a rectangle right here. The area of that is pretty easy to find because it's just length times width. So that would be 16 times 28. So the area of this part is 448. Then this part is a triangle, and what I'm going to do is I'm going to turn it just a little bit, and I'm going to say that this is my triangle with the base here. If this is the base, they're telling me that distance from here to here is 32. So I'm going to say all the way across here, the base of my triangle is 32. So the height I want to find would then be from the highest point above the base dropping straight down to the base. So basically from here to here. Now, they tell me that from here to here is 42, but this part down here is only 28. So if I take this section, which is 42, and I take away this part down here, which is 48, I should be able to find easily this part up here, which is the same as the height on the triangle. So, turning my page back the regular way, 42 minus 28 is 14. Okay, so that would be the length right here, from here to here, which, oops, to here, which is the height of my triangle. Alright, so the area of the triangle, again, I'm assuming that if I turn it this way, this is the base and this is the height. Formula for a triangle is 1/2 base times height, so it would be 1/2 times 32 times 14. So I get 0.5 times 32 times 14, which gives me 224. So all I have to do now to find the total area is add the area of the rectangle plus the area of the triangle together. So I get 672. They don't tell me what I'm measuring in, so we'll just call that units squared.